So today we're running SPSS and we are going to start comparing means by group. So as usual, we go to the Analyze menu, we say Compare Means, and in this case we're just looking at means. We're not going to do any statistics yet, we're just going to compare them. So it gives us a dependent list and an independent list. And the dependent list is the things that we want to get means on. So let's say the number of bedrooms, the number of bathrooms, and the sale price. Oh, and days on market. Why not do everything? And we're going to do this for each house type. Okay? So we're going to go into options just because we can. We're going to look at this, the mean, number of cases, standard deviation, and just for fun, the median. Let's move this around. So I'm holding down the mouse button and dragging so I can change the order that these things come out as. I say continue. I say OK. And here it is. We get our case processing summary, which as usual we're going to ignore. And we get our full report. So let's make this a little bigger. So it's important to look at the number of cases that are in each group. So for example, here we have the bi-level houses. The sample size is always n for number of things. And we see that there's just one house on the market which has beds, baths, price, and days on market information. But there's just one, so we're going to ignore this because one case of anything is kind of meaningless. So then we're going to look at ranch houses, and we've got 3 ranch houses, but that's really still not enough for us to really think is going to tell us anything serious. We would like to see preferably 30, but at least say 10 or 20 things, 10 or 20 houses before we can start feeling justified in making comparisons. So what we've really got here to look at is Cape Cods, the Colonials, maybe the split levels. And we can look at, here we see that the Cape Cods, they have an average of 3.6 bedrooms, 1.8 bathrooms, and the selling price was an average of about $326,000. And they spent an average of around 85 days on the market. If you have a Colonial, you're probably better off, because if you take a look here, there's actually fewer bedrooms, the same number of bathrooms, and the price is considerably higher. They get about $468,000 for these compared to $326,000 for the Cape Cods. On the downside, they spend 99 days on the market versus around 85 days, but that might be because they've got the higher prices. The medians are lower than the means, and that's true for all of these groups. And the reason for that is there's a certain minimum price that a house will sell for. The minimum price for pretty much any house in Teaneck is going to be around $100,000, maybe $200,000, whereas there's no upper boundary on the price for selling a house. So the problem with using averages is that they have a tendency to get thrown off by extremes at one end or the other of the curve. So when you have houses that are worth $2 million, where most of them are selling for, say, $360,000, the average will be way higher than it should be, whereas the median is a bit more stable because you're just lining up all the numbers and picking the one in the middle. So if the ones at the top are $5 and $6 million and all the other ones are $300,000, the median will be $300,000, but the average could be $400,000. So there's times when an average makes more sense, and there's times when a median makes more sense. So if you're looking at this and you're saying, well, if I have a 4-bedroom, 2-bathroom Cape Cod, how much can I expect to sell it for? Then $319,000 does seem indicated here, all else being equal. So here we've got the mean for each group, and here group is based on what type of house it is. So one group is Cape Cods, one group is Colonials, one group is ranches, one group is split levels. So you've got the mean for each of these variables. So the mean for beds, the mean for baths, the mean for price, the mean for days on market. Then you've got the median for each of these. And again, but since you can't be on the market for less than 0 days, then you can't get lower than 1 or 0. But you can get as high as 700 or 800 or even 1,000 because a house can just stay on the market for a couple of years. So the median will be lower. See, then you've got the number of cases. If you run it slightly differently, you can make it a little more compact, and you can also do clever things here. By double-clicking, you get what's called pivot trays. So you can move your statistics up here into variables. And now you might say it's easier to compare means because you can see them all right next to each other. Of course, you still have to go down to the sample size to see which ones are actually real. So again, to do that, you just double-click, and then you can move these things around to your heart's content, and it will reflect whatever you're doing, whether it makes sense or not. So there's all sorts of different ways to look at this. You're just changing the way that the table is set up. And then you get out of it the usual way. And this is cross-platform. It works the same way if you're using a Mac as if you're using Windows. So that was fun, but now we're going to get rid of it. So the two types that we can really compare the most easily are the Cape Cods and the Colonials, because we have 29 of one and 159 of the others. And I have a theory that Colonials sell for a significantly higher price than the Cape Cods. In other words, that the difference in price that I saw before is not just due to random chance, it's actually something that exists in real life. We'll go into variable view, here's style, and the ones that we're looking for are Cape Cods and Colonials, 2 and 3. Compare means, independent samples t-test, I say style, 2 and 3. And now I get this lovely output. So what do I do? Let's look at group statistics first. So group statistics is looking at each of these variables, and it says, okay, for price, there were 29 reports of price for Cape Cods and 159 for Colonials. Here's the mean selling price for Cape Cods, 326,471 about. And for Colonials, 468,396 about. And then we have the standard deviation, and look at that whopping great standard deviation. It is $213,881 for Colonials, so you know that there's a lot of variability going on. So there's probably some very expensive Colonials mixed in with the others. Now let's move to the independent samples t-test. And this is a little weird, okay? We're looking at whether there's a difference between the two groups. But there's two different formulas that we can use. And one of them is much more complicated than the other. So you've got your two different formulas, and the computer is not saying, I'm going to choose the correct formula. It's saying, I'm going to give you the information and do it both ways so that you can decide whether to assume equal variances or not. Now, typically what we do is we assume that you have equal variances if the significance of this f-test here is above 0.05. So what that means is that if the significance is at 0.05 or less, it means that there's a 5% or less chance that we are seeing differences in the variance due to chance. So essentially, if we have a low significance here, 0.05 or below, then we do not assume equal variances. So we go to the second line. If significance is above 0.05, then we assume equal variances and we use the top line. Now, I will admit, I generally don't look at this right away. First, I look over here. This is the significance for the t-test for equality of means. So this table is basically two tables in one. So here's one table here around Levine's f-test for equality of variances. I know it's an f-test because it has the letter F over there. And then there's this test over here, which is the t-test for equality of means. And that's everything to the right of this line, starting with T, going on to DF, which means degrees of, and all the others. Mean difference, by the way, let's just clarify one thing here. Mean difference sounds more complicated than it is. It's just one mean minus the other. So it's 468,396 subtracted from 326,470. So if I type this in, so if I take the mean, 326,470, 69, minus 468,396, 23, equals negative 141,925.54. And there it is there, different by 0.03 because they give you an extra decimal point here than they do here. Mean difference is just one mean minus the other. So for here, we would expect it to be 0.2 because 3.62 minus 3.42 equals 0.2. And here it is rounded 0.2. Again, they kind of mess things up by having an extra decimal place here. Let's go back to what we were trying to do. We were trying to say, is there a significant difference between price and number of bedrooms between Cape Cods and Colonials? And here we see that price, there is definitely a difference. Or to be more scientific, there is less than one chance in 1,000 that we would see such a large difference between these two, given these standard deviations and given the number in the sample. There's less than a 1 in 1,000 chance that we would see this huge difference just due to randomness and chance and weird factors. So that's a pretty big significance level, and we can say, all right, this is a big difference in price. We can see that with our eyes. It's $142,000 about. So we're going to say, okay, there is a significant difference between these two. The official way that we're supposed to say that is that we have to reject the null hypothesis that there's no difference. So for number of bedrooms, though, it's a little muddier. Here you notice that there's very little difference. 3.62 versus 3.42 bedrooms. And their standard deviations are not that high. First, we look at what line to look at. We cannot assume equal variances because this is significant, which means that there is a difference between the variances. So we go to the second line and we come down here and we see, aha, 0.093 is the significance. You got to reject that. Most of the time, if I'm doing one or two tests, I will set my criterion at 0.05. That means that 5 times out of 100, which is what 0.05 means, or 5% of the time, which is also what 0.05 means, I will see a, quote, significant difference, unquote, just by random chance. So 5 times in 100 or 1 time in 20, if I run 20 analyses and I use 0.05 as my criterion, in theory, one of them will probably be a false positive. Now, the thing is that if you're doing a lot of these tests, then you should use a lower level of P. P being the probability of getting a false positive. So what some people do is they just go down to 0.01 as their P. So they won't take anything that's not less than 0.01. And other people use what's called the Bonferroni technique. And that means that you take your P and you divide it by the number of analyses that you're doing, which in a case like this would mean that we have P equals 0.05. We divide it by 2, we get P equals 0.025. But if you're doing 100 analyses, it gets a little tough. You look at the F-test. If the F-test is significant, then you use this second line here, and you look at the significance for the t-test. Or you look at the significance for the t-test and you say, well, I'd reject this no matter what, and I'd accept this no matter what. So it doesn't really matter what the F-test says unless these two lines are saying different things. So if the significance was 0.02 for one of them and 0.12 for another, then you'd have to go through the work of doing the F-test. So that's basically the t-test. And the t-test is a very, very handy thing to know. It's very often handy to compare two groups against each other.